Hello, everybody. We are Team 21088, and our project was to design a process capable of manufacturing an environmentally friendly HVAC filter. We based our plant out of Phoenix, Arizona, because as we all know, Arizona allergies are incredibly difficult to deal with. So why not attack the problem at the source? Our mentor was Caitlin Schnitzer, and my name is Adrian Cabalfin. I'm here today with Aaron Deschner,
Hello, everyone.
Jonathan Russell,
Hello.
and Robert Anchetta.
Hello.
We're all majoring in chemical engineering, so let's get into it. In the 1950s, scientists invented a new material that would change the world forever: plastic. It's cheap, durable, sanitary, strong, and light. And as we've seen in the years since, incredibly difficult to get rid of once we are through with it. About 70% of discarded plastic winds up in open dumps, landfills, or the ocean. One product that many do not think of as a contributor to this problem are HVAC filters. The filter media itself is made up of the same polymers that make up the most commonly used plastic products. We made the assumptions that each building uses a standard 20 by 20 by 1 inch filter and needs one filter every 3 months. The most commonly used polymer in the manufacturing of non-woven fabric is polypropylene. Its low molecular weight and viscosity, as well as its narrow molecular weight distribution, make it the perfect candidate for non-woven processes. So to reduce the amount of plastic buildup in landfills, our group implemented polylactic acid, a biopolymer, into the filter media and designed a process capable of manufacturing it. The filter that we created needed to at least be able to filter out both dust and allergens. So with that now, I'm going to be handing it off to Aaron Deschner, and he's going to be talking about the comparison between a synthetic and a biopolymer.
Thank you, Adrian. So our goal as a team was to implement an environmentally friendly chemical that can be used in the HVAC industry. You'll see in the bullet points the major differences between polypropylene and polylactic acid, like the degradation time for polypropylene, which is 30 years, versus 24 months for polylactic acid. In terms of time, this is huge. So we know if we are able to implement this into industry, we know it'll skyrocket. We weren't able to reach MERV 13 with polylactic acid due to the MFI, which stands for melt flow index, and the properties it has. But we were able to reach MERV 8 that can filter bacteria, pet dander, and household odors. This is totally fine because we're aiming to design a process that will be suitable to mass produce filters for residential buildings. So with that being said, I'm going to pass it off to Adrian and Jack to present the next section in the poster.
Awesome, thanks, Aaron. Appreciate it. So a traditional melt blown process looks something like this. It includes the melt blower itself, which is composed of the extruder, die head piece, and winder. And the other unit ops include a resin tank, an auto feeder, and an air compressor. And we also decided to include another piece of equipment that isn't used commonly. But for now, I'm going to let Robert talk about the extruder.
So polymer extrusion is a process where raw plastic is melted and formed into a continuous profile. The process begins by feeding plastic material from a feed hopper into the barrel of the extruder. The barrel consists of 3 zones: the feed zone, the compression zone, and the metering zone. The material is gradually melted by mechanical energy generated by turning screws and by heaters arranged along the barrel. The molten polymer is then sent into the die head piece, which shapes the polymer.
Thank you for that, Robert. So now I'm going to be talking about what happens after. So after the extruder, the polymer is delivered to the die head piece. The die head piece we have is modeled after an Exxon die head piece. The spinneret hole is shaped like a triangle, which allows for more product to be distributed, and there is no buildup of polymer in the orifices. Now, once in the die head piece, the air compressor sends air, and it sends it at around 1200 cubic meters per hour. And from there, after that, it shoots the polymer through the die head piece onto a conveyor belt. And once it is there, the polymer becomes a uniform piece of material. After that, a few meters down is the electret. The electret or corona charging device consists of a high voltage power supply and an apparatus capable of delivering a charge. Essentially, the corona charging device or electret charges the filter, and once that is through, the filter efficiency improves. So now that I've talked about the melt-blown process with Robert, I'm going to talk a little bit more about the safety of our process. So PLA is a slightly hazardous material. It is relatively safe to handle, but wearing safety goggles and covering skin is highly recommended as it can cause serious eye injuries and irritate the skin. The melt-blown process is safe as well. The largest hazard is the high temperature that the process gets up to. Once again, we recommend that skin is covered and that safety glasses are worn when operating the process. So now with that, I'm going to hand it off to Jack or Jonathan, and he's going to talk about the cost.
Awesome. Thank you, Adrian. Beginning with the revenue produced, we took the amount of filters that we produced and multiplied by the amount of cost per filter. And the amount of filters produced, we based that off of reaching 13% of Arizonans now going, and the revenue was $29 million. Now going over the equipment cost, we were able to get into contact with a couple manufacturers like Filtration Technologies to actually get quotes for the equipment that we use. And now going into the labor cost, we were able to find the cost of labor for the different engineers that we were going to use and the technicians that we were going to use. And we multiplied the hourly cost for all employees by how many hours we were operating per year. And that came out with a labor cost of about $1 million. The utility cost we got from when we sized all of the equipment, we found how much energy they actually needed. And by finding the amount of kilowatts they needed, we were able to find the price of energy in Phoenix per kilowatt hour. And by multiplying the amount of hours in operation and the kilowatts needed, we were able to come up with the utility cost. We were able to get the land cost by when we sized all the equipment, we were able to find out how much area they actually used, and using that area and a little bit extra, we multiplied by the cost of land in Phoenix, and that came out with the $11,000. The raw materials that were used were the PLA, and we used about 1.5 tons, and that's where that cost comes from. And the shipping and handling and income tax were accounted for below, and that produced a net earnings of $24 million. Now I'll be taking us over the conclusion. So all in all, we were successful in terms of most of our goals, except for the not reaching the MERV 13 stretch goal, which we originally wanted to actually filter out the COVID-19 virus. And we were also successful in implementing a melt-blown process for the PLA when it is traditionally used for polypropylene. For improvements for the future, we would just need to do more research and find out a better way to actually use a non-traditional biopolymer like PLA as the filter media. And for closing remarks, we wanted to say thank you to Caitlin for all of her support, and thank you to the faculty that were supporting us, and thank you for your time as well.